Good morning, students. Today we will discuss concept-based theorem. In this theorem, we will use the concept of total probability. And what is total probability? Let's discuss. Let's read the paragraph which is given here. Consider that there are two bags, 1 and 2. Bag 1 contains 2 white balls and 3 red balls. And bag 2 contains, just Bag 2 contains 4 white balls and 5 red balls. Here I have drawn, this is the first bag, this is the second bag, and this is B1 suppose, this is B2. And first bag contain, I have to write down white 2 balls and red 3. In the second bag, white 4 and red 5 balls. Okay. One ball is drawn at random from one of the bags. We can find the probability of selecting any of the bag. Here are 2 bags. If you want to select any one of the bags, it means what? Probability will be 1 by 2. Because you are choosing one, favorable case 1, and total bags are 2. It means 1 by 2. Or probability of drawing a ball of a particular color, say suppose white, from a particular bag. In other words, we can find the probability that the ball drawn is of a particular color if we are given the bag from which the ball is drawn. But can we find the probability that the ball drawn is from a particular bag? It means what? First case is what? Ball is drawn from the first bag or the second bag? No. Question is, ball is drawn and it is drawn from the particular bag. Can we find the probability that the ball drawn is from the particular bag? Ball is already drawn and it should be from the first bag, maybe from the second bag, like this. If the color of the ball drawn is given, it means given part is which color of the ball you are drawing from the bag. We have to find the reverse probability of the bag 2 to the selected when the event occurred after it is known. It means suppose the ball drawn is red ball, and that red ball is drawn from the second ball. If you want to find out this type of probability, that type of case is known as the Bayes theorem. We will do such type of questions by using the Bayes theorem. To be selected when the event occurs after it is known. Famous mathematician John Bayes solved the problem of finding reverse probability by using conditional probability. The formula developed by him is known as Bayes theorem, which was published in 1763. Before stating and proving the Bayes theorem, let us first take the definition of some preliminary results. Partition of sample space. It means a sample space is divided into n events, E1, E2, E3 and up to En, and all these are disjoint because intersection of these all events is equal to empty set. It is given to you. Partition of the sample space. Now this partition of the sample space and the points which are written here, first is written all the events are mutually disjoint, and if you make the union of all these events, you are getting the sample space, and the probability of each event is always greater than 0. These are 3 conditions when you are doing the partition of the sample space. Now the use of this partition is in the theorem of total probability. Let's see. Here is a one diagram is given to you. Whole rectangle is showing a sample space. This whole rectangle is a sample space like this. Suppose this is a sample space. E1, E2, E3 are the events. Suppose these are the events like this. All these are disjoint. They are not having any element common. Suppose like this. Okay. These are the partitions which are mutually disjoint. Now here is one event. Suppose this is an event A like this. This is the event A. You want the probability of this event A if these partitions are given to you. Now this is the total probability. Now here we have to read E1, E2 and up to En be the partition of the sample space S, and suppose that each of the event has non-zero probability of occurrence and no one have probability equal to 0. Let A be an event associated with S. That A is drawn from the sample space S, whose partitions are made. Now, how to get the probability of A if E1, E2, E3, and En are there in the sample space? Now, this is the formula to calculate probability of E1 into probability of A if E1 happened, plus probability of E2 into probability of A into E2 happened, and up to N. This is a formula to get the total probability. Now we will use this total probability formula to find the Bayes theorem. First we will discuss one example related to the total probability. Here's the example number 15. A person has undertaken a construction job. The probabilities are 0.65. That will be, there will be a strike. Okay, probability when there is a strike is 0.65 and 0.80 that the construction job will be completed on time if there is no strike. You have to just read the statement very carefully, what is given in the question. Now here is the first thing, probability when there is a strike is given to you. Probability when there is a strike. If you know the probability when there is a strike, you can calculate the probability when there is no strike. It means total is 1, and when 1 minus probability of drawing the strike means no strike can be calculated, that is 0.35. Second thing is given 0.80 is the probability of constructing work will be completed on time if there is no strike. Work is completed as a event. Strike is there or no, there is no strike. The two cases are there as E1, E2. But A is what? Construction work should be completed. Maybe whether there is a strike or whether there is not a strike. Work should be completed. It means work should be completed when there is a strike, and where there is a not strike, both probabilities are given to you. When there is a strike, it is 3.32, and when there is a strike, doesn't strike and work is completed, that is 0.80. This is the case. Now you want to calculate probability of A, work completed. First case, if there is strike and work is completed. Strike is 0.65 and work is completed if there is a strike is 0.32. Second case, when there is no strike, that is 0.35. Work is completed when there is no strike is 0.8. Multiply these two statements and add them, you are getting the total probability, that is 0.488. Here the whole sample space is S. Two parts are there. First, there is a strike and there is no strike. It means E1 and E2. You can see here we have written B and B dash. Now this is A. This is a circle. Work is completed when there is a strike. Work is completed when there is no strike. Like this. You have to understand the question. Now this is a total probability case. Now come to the case when we use this total probability in the next theorem, that is a Bayes theorem. Now question is now I'm just telling you again, here is a sample space S. In the Bayes theorem, what you have to calculate? These are E1, E2, E3, E4, E5 and up to En. Okay. Now this is A. You can see here, this A is touching to all the partitions. This is the A. Now you want the probability. This A is already happened, and this is happened in E1. You have to calculate this one. Like this, suppose there are two bags. Suppose these are the two partitions of the sample space. Balls are there, white and red, and you know what is the probability of red ball to picking from first bag or a second bag. Now to get the red ball, you know the probability. Now you have to find out the probability of that red ball is drawn from the first bag. That red ball will be drawn from the first bag or maybe from the second bag. This is you have to calculate. Now you know the total probability, that is written here. From which bag you want to find out the probability? Suppose it is from the first bag you want to find out, then first bag probability should be in the numerator. Probability of EI into probability of A if EI happened. It means we are here taking 1 and 1 here. If it is from the second bag you want to calculate, it should be 2 and it should be 2 here. It means from which bag you want to find out the probability, that will be in the numerator, and total probability will be in the denominator. Let's do the question, then you can understand very easily. Suppose here is a example number 16. Let's. Bag 1 contains 3 red. Bag 1 contains 3 red ball and 4 black balls. Second bag contains 5 red balls and 6 black balls. One ball is drawn at random from one of the bags and it is found to be red. Now the probability you want to find out, it should be drawn from the second bag. Now this is suppose E1, this is suppose E2. These are two bags. E1, E2 are the two bags. Now probability of picking a bag, whether it is E1 or E2, that is always 1 by 2. Two bags are there, and one bag you are selecting 1 upon 2. Three bags are there, it is 1 upon 3. Now probability of red ball, that suppose red ball is A. A be the drawn of red ball. A is the event drawn red ball. You are drawing a red ball if you have already picked bag 1. From first bag you have to find out the probability of red ball. That will be 3 by 7. Probability of red ball from the second bag, that will be 5 upon 11. Now your part to solve is, you want to solve the probability of that red ball should be from the second bag. It should be drawn from the second bag and it is red. This you have to calculate. Probability of drawn ball is from the second bag and it is of red color. Now what is the formula? Formula will be probability of E2 into probability of A if E2 happened, because you want a total probability in a denominator. Total means probability of, total means I have to write down total probability means two bags are there. It means probability of E1 into probability of A if E1 plus probability of E2 into probability of A if E2 in the denominator. It should be written in a denominator. Let's see. Yes, this is the formula. Because you want that ball should be from the second bag. That's why E2, and it will be of red color. Now second bag probability upon total probability. Total means two bags are there. It means first bag probability and second bag probability. This is the answer. I think you can understand now. Now here's the next example, example number 17. I think you can put the values in the previous example, because I have told you what are the values. Just you have to put the values. Just you have to calculate. Now, given 3 identical boxes, 1, 2 and 3. Now 3 boxes are given to you, each containing 2 coins. First, second, third. Each is having 2 coins. Each is having 2 coins. In box 1, both coins are of gold. This is 1, this is 2, this is 3. Both are of gold coins. In box second, both are of silver coins. In box third, one is of gold, other is of silver. A person chooses a box at random, takes out a coin. If the coin is of gold, what is the probability that other coin in the box is also of gold? Now, first of all, box is chosen. Probability to pick the box is 1 by 3. All boxes probability, suppose this is E1, E2 and E3, then probability of E1, probability of E2, probability of E3 all are 1 upon 3. Now, you want gold coin. To get a gold coin is A. Gold coin is A. Now, probability of A, if E1 is chosen, probability of A if E2 is chosen, you have to calculate all this. Probability of A if E3 is chosen. Okay. Now, second coin should be of the gold. It means it is only possible in the case of first only, because 2 coins of gold are there in the E1. You want to calculate probability of E1 if A already happened. This is the if sign. Probability of E1, A happened. Now, what is the case to solve probability of A if E1? First case, probability of getting gold coin 2 out of 2, that is 1. Probability of gold coin from the second bag, not possible because both are silver coins. 0.2, it means 0. And to get the gold coin from the third bag is 1 by 2. Now here is the calculation for E1 if it is a gold coin. This is a formula. Now here is a formula. Because you want, it should be second coin should be of the gold coin. It is possible in the case only first case. This should be understand through the statement. Only 2 gold coins are in a first bag only. So even if it is a gold, second coin will be a gold. Now apply the formula. From first bag probability, it is in the numerator and total probability will be in a denominator. Now put the values. All are calculated. Just put the values. You will get the answer. Suppose that the reliability of the HIV test is specified as follows. Of people having HIV, 90% of the tests detect the disease, but 10% go undetected. Of people free of HIV, 99% of the tests are just negative, but 1% are diagnosed as showing HIV positive. From a large population of which only 0.1% having HIV, one person is selected at random, given the HIV test, and the pathologist reports him or her as HIV positive. What is the probability that person actually has HIV? Now here you have to understand, in a population, few people have the disease HIV. When they go to the lab and tested, they diagnosed the HIV and they don't have HIV. They diagnosed and they have HIV. There are 2 cases. They have a disease and they diagnosed as having HIV, but they don't have disease. Even then, sometimes it is diagnosed they have disease. Now, you have to just write down the statement, what are the values given to you. Here, one is the case when when the person goes to the lab and he has HIV and diagnosed HIV. But second case is what? A person don't have HIV but diagnosed as HIV. Now question is, now you have to just write down, E denotes the event that person selected is actually having HIV, and A, the event that the person HIV test is diagnosed as positive. We need to find out the probability of E if A already happened. Now E naught denotes the event that the person selected is actually not having HIV. E is having HIV, E naught is don't have HIV. And A is what? A is the event that the person has HIV and diagnosed positive. Okay, have HIV and diagnosed. In a path lab, it is also diagnosed positive. Now, probability of having HIV means it is given, that is what? How many are having HIV? Just check it. From a large population of which only 0.1% having HIV. 0.1% means 0.1 upon 100, or when you solve it 1 upon 1000, it means 0.01 is the probability of having HIV. Not having HIV, 1 minus 0.001, that will give you probability of not having HIV. This is 0.999. Now here's a question. A means diagnosed HIV and he has HIV. Diagnosed HIV and he has HIV. Both are the statements. Listen carefully. Diagnosed and he has. This is given to you 90%. It is 90 upon 100, 0.9. Second is, he diagnosed HIV, but he don't have HIV, E naught. That is given to you. That is 1%. That is 0.01%. Now our solution requires probability of the person who have HIV and diagnosed. Have and diagnosed. Okay. The probability will be probability of E into probability of A if E happened, and total probability. Put the values and you will get 90 upon 1089 and simplify it. The next question is related to the manufacturing. In a factory, which manufacturers board machine ABC manufactures respectively 25%, 35%, 40% of the boards of their outputs. 5, 4, 2% are respectively defective boards. Okay. A board is drawn at random from the product. It is found to be defective. What is the probability that it is manufactured by the machine B? Okay. Defective, and it is manufactured by machine B. Now here B1, B2, B3 are the board manufactured by the machine A, machine B, and machine C. Now let the E means where maximum time we have taken A as a event. Here I am taking E here because E is written in the book. At the place of A, we are using here E. E be the bolt is defective. And this B1, B2, B3 are the bags E1, E2, E3 like this. So event occurs with B1, B2, B3 given to you, that is 25%, 35% and 40%. Probability of B1, probability of B2, probability of B3. Now bolt is defective and it is from the B1, that is given 5%. Bolt is defective and it is from the B2, it is 0.04. third one is also there, should be. Yes, bolt is defective, but it is from the B3, that is 0.02. Now our question is, it should be from the second manufacturer, that is B2. Now B2, from B2 and it is defective. It is from B2 and it is defective. You have to calculate now. Now probability of B2 box divided by total probability. Now put the values. A doctor is to visit a patient from a past experience. It is known that the probabilities that we will come by train, bus, scooter, or by the other means of transport respectively, 3 by 10, 1 by 5, 1 by 10, 2 by 5. The probabilities that he will be late are 1 by 4, 1 by 3, 1 by 12. Okay, means of transports are given, and when he is late, it is given to you. If he comes by train, bus, and scooter respectively, okay. By other means, he is not late. But he comes by other means of transport, then he will not be late. When he arrives, he is late. What is the probability that he comes by train? Okay. Now, here means of transports are taken as T1, T2, T3, T4. And he is late through the means it is given. First is given. First mean, second mean, third mean, and fourth means of transports are given here. Probability. And E means he is late. He is late and he comes from train. 1 by 4. He is late and comes from the second transport means, that is 1 by 3. And from the third transport means, it is 1 by 12. And he, when comes from the other means of transport, he is not late. That's why it is 0. Now we want to calculate he is late. He is coming from train and he is late. Coming from train and he is late. So put the probability of T1 into probability of into E. If T1 happen, T train से आता है और late हो जाता है. And total probability, first means of transport, second and third and fourth. Add the put the values and add them, and you will get the solution. When he is not late, it means probability will be 0. This should be important to learn. Next one is, a man knows to speak truth 3 out of 4. Okay, how many times he speaks the truth? 3 out of 4, 3 by 4. He throws a die and reports that it is a 6. What is the probability that it is actually a 6? It means 6 comes and he told 6 comes. Or second thing, 6 doesn't come and he told 6 comes. Okay, telling lie. Now let B be the event that man reports the 6 occurs in the throwing of the die. E means E is the report of telling the 6 comes. S1 be the event 6 comes. S2 the event 6 doesn't come. Probability of 6 occurs is what? If you are throwing a die, the probability will be 1 by 6. 6 is not coming, other elements are coming. It means probability of not coming 6 will be equal to 5 by 6. Now, 6, E means he reports 6 comes and 6 comes actually. He reports 6 comes, but 6 doesn't comes. He reports 6 is there and experiment also shows 6 is there. He shows reports 6 is there, but 6 is not there. These are the two cases. Now, when he tells lie or when he speaks truth, man speaks the truth is 3 by 4, and he is telling a lie. It means 1 minus 3 by 4. It means he is reported wrong. 1 by 4. Now, 6 comes and he tells 6 comes. He reported same as it comes. It is the probability you have to calculate. It is probability of S1 if E already happened. You have to calculate the probability of which you have to calculate. That will come in a numerator and total probability will be in a denominator. Put the values and you will get the answer. These are the questions related to the Bayes theorem. Now you have to try the exercise 13.3. This is a very important exercise which you have to do your own. I'll send you PDF of the solutions of exercise 13.3. Just first you have to try. Thank you. Have a nice day.